Okay. Computers mimic human reasoning by building on simple rules and statistical averages. Having your strategy against the computer in this rock, paper, scissors game illustrating basic artificial intelligence. These computer novice where the computer learns to play from scratch and veteran where the computer takes over 200,000 hours of previous experience against you. Okay, so the computers, they're claiming that the computer will learn over time and will be able to predict whether or not you're going to throw rock, paper, scissors. Now, do you guys know what rock, paper, scissors is?
Can you demonstrate?
You just want me to make a fool of myself, don't you? Okay, so rock, paper, scissors is a dumb game where you like can figure out, not dumb, I don't know, figure out who wins. And you go like, okay, we'll go rock, paper, scissors, shoot. And then I lost because I had paper and he had scissors. And anyway, rock beats scissors and paper beats rock and scissors beat paper. You don't need to know any of that to be able to do that, but it makes it more fun. Okay, it says, so what we're gonna do is see if the computer actually is learning or if it's just using random generation like us. So use a random number table. We're not going to do that. We're going to use randint on our calculator to determine whether you will throw rock, paper, or scissors against the computer on novice and veteran mode. You will conduct 30 trials for each expertise level and record the outcome of the game as win, loss, or tie. Describe how you will use the random number table to determine your play. Okay, so this is the part we for sure need to do together. Okay, this is back from chapter 4. Just so you know. And what we're going to do is let the digits 1 through 3 be rock. 4 through 6 be paper. And 7 through 9 be scissors. Now, technically, we could just say let 1 be rock, 2 be paper, and 3 be scissors. But because this is talking about a random number table, which would have all of the digits 0 through 9 in it, I wanted to be consistent with what they were doing. So we're just going to ignore 0. We're actually not even going to talk about 0 at all. So 1 through 3 is rock, 4 through 6 is paper, and 7 through 9 is scissors. No. Yes, actually, sorry. Okay, now just because I'm a stats teacher and I can't resist, what does the 191 mean? That's a very good guess. Anyone else have anything to add? Think about
I do know, what, middle is 1,
Yeah.
9, and then
low,
high, and how many you want?
how many you want. Okay,
Yeah.
nice. Okay, so it's telling you, you're telling the calculator, I want numbers from 1 to 9, give me 1 at a time. You're gonna want 1 at a time. Trust me, I played with this last night on the couch. 1 at a time's is the way to go. Poor Mr. Talbot had to make dinner because I was all busy rock, paper, scissoring. Okay, so we had, we're gonna do 30. Oh, also, I did not put rand it no repeat
first of all, that doesn't apply because I'm asking for one number at a time. And also, we don't care if there's a bunch of rocks in a row. That happens a lot when people play rock, paper, scissors. A lot of times I'm going to do rock and then rock again to try to fool you. So anyway, okay. The good news is the computer will calculate all of the it'll add it all up for you so you don't have to. Okay, so going to the computer, it should look like this. And we're all going to start in novice mode. So click the novice button. Okay. Make sure you have that up. And there's nothing to write. So let's discuss, if you guys can remember, go to math, probability, rand ints. Okay, now you guys need to use your own data, not mine. So this is Mrs. Talbot's lab, not Jamie's in the pajama pants lab.
Put the data down or not?
No. Okay. Well, I just liked you looked cozy.
Oh, no, I was making fun of Grace.
Oh, okay. Anyway, so hit enter. My first one is scissors. Okay, so
Well, I was actually dying here.
okay, so what helped me when I was on the couch last night doing this.
Great.
Everyone's online, that means our calculators are all.
Yeah,
not
right,
together
right,
manually. We need to see them again.
Great. You do it again. So you get
Okay, hold on. We all have brand new calculators.
What are we doing there? Play Minecraft. Wait, stop it. It's a random. You don't know, man. Where's the other that? No, without it, we'll wait.
Okay, all right, okay, so everyone, we need to see the calculators because they've been cleared. Go to the top, unless you already seeded your calculator. Put your student ID in. Anything, any number. I just say student ID so you don't think about it too hard. Then hit, excuse me, please pay attention. Then hit the stow button. Stow is short for store. I don't know why they couldn't fit the RE on there and not put the arrow, but whatever. Stow is above the on button that you hit every day. Okay, and then math, probability, rand. Enter. Okay, now we should all get different ones. You just told it where to seed you in the number table that exists in it. We were all starting at the start before. Okay, so okay, now back, let's just pretend I didn't do anything. So back here, rand int 191. Okay, 7. Oh, I still got scissors. Okay, as I was saying, on the couch, when I was doing this, I just imagined the rock button had a big 1 through 3 on it, and the paper button had a big 4 through 6 button on it, and the scissors had a big 7 through 9 button on it. Does that make sense?
Yeah.
Okay, so I got scissors. I got a 7, so I hit scissors. Okay, don't write anything down on your paper. There's no need. Okay, now just shh, guys, just hit enter on the calculator. Oh, now it told me to do rock. So click rock. Hit enter on the calculator. I got scissors again. Hit enter on the calculator. Ooh, I got paper this time.
Okay. You guys are going to keep going until these three numbers add up to 30. Are you with me?
Yeah.
Okay, so you're gonna go until those three numbers add up to 30. Then you're gonna write those in the novice spots on that table. Then you're gonna refresh the window. You're gonna change it to the veteran mode, and you're gonna do it again until the three things add up to 30. Are you with me? Okay, go for it. Let me know if you need assist home. The three numbers. Yep. You're at 4. Oh, it's not 301. I see what you were saying. What?
Oh.
It says novice first, then veteran. Wait. Oh, yeah. No. So this is the veteran? Veteran. Yeah.
Okay, so I finished my novice one, you know. Oh, I don't know what round I got my first one. Hold on. I gotta look back. Oh, I don't know. Well, I want to let you. I think it was the first round, but Well, do it on the veteran one then. You guys, if you did not log what your first win was, just do it on the veteran one. I did the whole thing. It doesn't mess with the data.
Oh, the novice one. Putting how many times I went.
5 Jimmy.
I just copied out of the 3 boxes and then, but on the veteran one, Nami, just make sure that you figure out which one was your first win.
I'm not gonna come back. With that.
Oh, mine was the 3rd.
Well, one. Kind of made it crazy. Ten wins. Yeah.
Okay, you can wait for me for the hypotheses. I'm almost done. All right, you guys, make sure that your when you're ready, your table looks like mine. It's got totals and things. Okay. Then flip the page when you're ready. Okay. Number three, a truly random game of rock, paper, scissors would result in a statistical tie with each player winning, tying, and losing 1/3 of the time. However, people are not truly random and thus can be studied and analyzed. While this computer won't win all around, over time it can exploit a person's tendencies and patterns to gain an advantage over its opponent. This is why we're using a random number table. Test whether the computer output is truly random regardless of the mode using a statistical hypothesis. Use alpha equals 0.10. Okay, so state. Okay, now this one, and the reason I wanted to help, first of all, was because the hypotheses are kind of, they don't give you like what to say necessarily well. But which test do we do? We have three of them. So we have goodness of fit, we have homogeneity, and we have association. We've learned all of those. And when you're talking about a distribution across groups, that one is goodness of fit. And the weird thing about that is goodness of fit has to be a list, not a table. So we're going to work in totals. Okay, so okay, what I want you guys to do is find your observed counts in your data, and that's going to be your three totals. So 2016, 2016, and 26 for me. So whatever these three totals are at the bottom. Okay, now what I'd like to talk about is how do I find expected counts for a goodness of fit test again? It's been a few days. Does anybody remember how to do it? If not, you could look back at your 12.1, 12.1B and the table that we copy and pasted in for 12.1B. How did we, how do we find the expected?
How was you wrong?
What?
You wrong, so you're wrong.
Are you on the observed? You should use your own. Everyone's expected should technically be the same, though. That's kind of a trick question, shouldn't they? Exactly. Okay, so I'm looking for the total 60 times 1/3 probability here. 60 times 1/3 probability here. 60 times 1/3 probability here. Or you can just use common sense and say if they're equally likely, then it should be 20, 20, and 20. Yes, honey? No, I just want to see the 20, 20, and 20. Okay, now for this one, there's only 3 chi-square terms, so I suggest just doing it by hand. It's up to you. Especially because if you have any that are exactly, then that makes 0, which is great. Remember, all of us in the whole room should have different numbers. Oh, Mrs. Talbot, I just happened to get 2016 and 26. No, you didn't. No, you didn't. They don't?
No.
Why didn't you say something before? Oh, that's because I can't add. Nine. To what? No. Everyone should be different. Mine doesn't equal 2.6 actually. Thank goodness for Whiteout and Jake. How many degrees of freedom are there on this? 2. Well, that's just disappointing. I really thought, was it? No, it was not.
No, didn't do like that.
And then I ended it with my emotional note. I don't really necessarily believe that it's learning. Okay, now you're gonna be excited. If you could all get out your formula sheets, please. Formula sheets. Yellow.
Yeah.
The next page is actually our first beginning to review for the AP exam. To be honest, this was our first beginning to review for the AP exam, but now we're going to continue reviewing for the AP exam. The next page does not have anything in chapter 12. But to be honest, my last year's student said that there was one thing that they wished we would have reviewed more, and this was it. Okay, number 4. Assume that the probability of you winning was purely theoretical. Answer the following question. It's not unit 4 for us. It's unit 6. Assume that the conditions for Bernoulli trials are satisfied. What does that mean? That means that the conditions for it being a binomial distribution are satisfied. This page is binomial and geometric. Oh, fun. Okay. How many rounds would you have to expect to play until you obtain your first win? Okay, so blast from the past. First, binomial or geometric? I didn't ask any of that. I said binomial or geometric when it says the word first in it.
No idea.
This one is, it's not. Geometric. Okay. Geometric. Okay, and I want to remind you that expect means expected value, which is the same thing as the mean. I would like you to locate the mean of a geometric formula on your yellow sheet, please. What is the mean of a geometric?
1 over P. 1 over P.
Okay, and what is the probability that you win 1/3? Keep change flip. 3 throws. So you expected to have to play 3 throws until you get your first win. I had it on 3 actually. But actually, I don't know what it was on the novice, but on the veteran it was 3 because I forgot to keep track. How many rounds would you expect to win out of a fixed number of trials? 15. Is this binomial or geometric? But it is 5. Please slow down. Binomial has a fixed number of terms. What is the formula for the expected value of a binomial? N times P. Beautiful. Look at all this review. Okay, what is N in this problem? 15. And probability? Oh, this is, you could end this in rounds, I guess. Rounds, throws, same thing. How many rounds did you have to play until you obtained your first win? There's no math here, you just write it down. Mine was 3. What is the probability that you would obtain your first win on the round that you did? Okay, first, binomial or geometric? Yeah, nice. Okay. That is incorrect. It's PDF. Yeah, it's exactly 3. So don't use 3, by the way. Use whatever number you wrote here. Okay, now go back in the calculator. What does Geomet PDF require? Probability and X value. What's the probability? 1/3. And then X value is whatever you put here, not what I put there. Okay. Last one on this page. What's the probability that you obtained the number of wins out of the 60 total? So fixed number of trials, 60. Binomial or geometric? Okay, and how many wins did you guys have? I seem to have had 20. This is the number you're looking for right here. So get this number from here. And what does binom PDF require? Yeah. Okay, flip. Okay, now, by the way, this number 9 page, this whole page is optional. You won't have time unless you just really thought that this was super cool. You could do it later on your own. I didn't even do it. What you do is you do it again, but you try to beat the computer. You don't use the random number generator. So anyway, but we're here. No, we won't have time. What is the, you're not gonna have time to finish all this, but I'm gonna get you going enough that you can finish it, because this is the homework. So what was was the novice mode actually easier to win? Test whether there is an association between the level of expertise and the outcome of the game. Okay, which test is this? Mm-hmm. Chi-squared test of independence association. Okay, now the random condition in this test is exactly the same as the goodness of fit. I'm not going to do it again. The 10% condition is also exactly the same as it was in the previous one. I'm not going to do it again. But the large counts condition is going to be different because you're working with a table this time and not a list. Okay, what table do you think that you're working with? Here she is here. Okay, so this now becomes your two-way table. And you're going to put this into matrix A. And you guys know how to put the expected into matrix B? Do you know what I'm talking about? Do you know of which I speak? Row total times column total divided by total total. It's going to go into matrix B. No one? No one knows the words of which I'm speaking? Okay, so this is where I'm going to leave you. If I were you, I would just make a little guy over there to put your expecteds in. Okay, now quickly, actually, the next question, it will depend on if you reject or fail to reject, whether or not you have a type 1 or type 2 error possibility. The back page, I have to be completely honest with you, is almost exactly the same. You guys remember the chi-square test of association and homogeneity are almost exactly the same. What are the things that are different between association and homogeneity? Does anybody know anything that's different between the two? Yes, the hypotheses are different. So it says, is it distributed the same? Is it not distributed the same? Okay, there's one more thing that's different. I appreciate the flipping through the notes. I like it. What else is not the same? Hypotheses and You're comparing 12.2A and 12.2B. Look in the plan section. Okay, let's show you the underlined part. Homogeneity has multiple random samples. So you can't just go assume 60 is a random sample. You have to break it up into 30 and 30. Same thing for the 10% condition. You have to check separately for the 30 and 30. Okay, but everything else is the same. The expected counts are the same. The do is the same. You can just copy the numbers straight over from the other page. Like I wouldn't even show my work or anything. I would just copy it straight from the other page. Do you know what I'm saying? Like don't redo everything. Just redo the parts that are different. Okay, so let me show you real quick. When I did this on the couch last night, here's my test of association. And then when I got to this, I wrote the hypotheses, I did the plan properly, and then I just got the chi-square value and the p-value from the other page because it's the same math. You see what I mean? I didn't do expecteds again. I didn't do anything in the calculator again. I'm really sad though, because I really thought that I was gonna get reject the null hypothesis and the thing was learning. Did anyone reject the null hypothesis? Not one person? The computer's not as good as they say.